I'm sorry if for some people this is the third time you've seen this presentation. So I gave it first at DNS OARC in May last year, just before the RIPE conference in Poland, and the first person to ask a question and put his hand up was Paul Vixie, and I nearly shat myself. This is entitled Anycast on a Shoestring, and originally it was entitled Anycast for Shits and Giggles, but Claire, my wife, said I wasn't allowed to call it that. So this is a little bit about me. I've done some consultancy for a number of years for service providers and enterprises around the UK and in Europe. I now work at Cumulus Networks. We do run a team where we do sort of DevOps networks automation. I'm a board member for UKNOF. I live in West Wales and an aspiring lighthousekeeper. So I guess with this audience, 90% of people understand what Anycast is. You announce the same address space from multiple locations, and based on BGP attributes, traffic will select the best path, sometimes the closest location, or one that's usually nearer, or you might deploy nodes to localize traffic. The benefits of this is for increased reliability, to do load balancing, improve performance, and localize the impact of a DDoS attack. So in summary, I fancied deploying an Anycast service, and I was really motivated by two presentations of PDFs that I'd seen online. I hadn't seen these in person. The first one of these was Bill Woodcock from Packet Clearinghouse. He did a presentation at Sanar Gate, best practices in Anycast service provision. That really good, excellent slide deck into looking into how Anycast works. And the other one was from Dave Knight, and this was about dense Anycast deployment. And Dave in particular showed how I think it was ICANN at the time, they used Puppet to deploy hundreds of nodes really quickly using DevOps techniques. And I wanted to gain more experience of automating these sort of distributed environments. So my thoughts were, could I do it without spending too much cash? And what did I want to offer? So initially I thought I'd only offer secondary DNS on v4 and v6. And because I was kind of cobbling it together, it's a free service with no SLA, and I'd take no revenue. And more importantly, Claire wants to move house, so I had to do it without her finding out. So I set myself a kind of budget of $1,000 a year that I wanted to run it for. So what were the requirements for building it? So I needed to have it a separate network from my existing management network. I had a spare /24 PI and 48. So I applied using the right ASN form to just get a new ASN, and I got 60564 pretty quickly, within a couple of days. I needed to automate it so it wasn't too much effort to run, and I wanted to play with some new tools. I also thought it'd be great to give something back, so I've all the code since I started writing it, I put it up on GitHub at this repo on this address that you can see here. So what does the network look like? I've got a bunch of nodes around the place, and I announced the same /24 and /48 via BGP in each location. So you have lots of nodes, and they all announce exactly the same space. Typically, between my node and the upstream provider, there's usually like a /30 or a /64. For some providers, it can really vary. I can be on a 24 or in the middle of somebody's like /29 if they're /29 of V6 if it's maybe their first V6 deployment and they haven't got a clue in the world. I typically don't accept any routes. I point the static route of my VM back at the provider and just make the announcement. In some cases, some of these providers don't even have full tables to send me. How was I going to manage it? I was using sort of open clear text protocols, so I wanted to build a management framework over the top, like an overlay network. So I have all my Anycast nodes spin up an open VPN tunnel back to a single management location. Over that, I announce a /32 of RFC 1918 space, and I use that to manage the box. This kind of simplified things because it meant I didn't have to use any TSIGs to protect the zone transfers. And it meant that all my application traffic that I was managing the whole environment with, such as Beanstalkd for the message queue, my API, and the zone transfers could be in clear text, but they were protected over this management tunnel. So how to get the zones into the environment? So what it was offering was secondary DNS. So typically people that signed up already had their own primary DNS server. So at the top, there's some master servers operated by others. And inside my management network, I had a zone transfer box called AXFR. And that box would take zone transfers in from third parties, from anyone that signed up. And then over my OpenVPN channel, I'd transfer the zone back out to all my Anycast nodes. So this meant that each of the end locations where the DNS servers were didn't need to each make individual calls to the source of the original zone. And this also supported trickle-down notification, so someone could send a notify to the AXFR, and what it would do straight away is send the notify on to all the Anycast nodes. One problem I found when some people are using this is they try to send the notify to the actual Anycast address, the ns1.esgob.com, and that just doesn't work because that address is Anycasted, and it's not set to accept any notifies or honor that from any other location than the transfer box. And sometimes I'll look through my logs and I'll have to write back to someone and sort of educate them. So I wanted to make it super easy to store all this metadata about both the domains, and I didn't want to do any manual configuration because that sucks. So I stored all the configuration for every host in JSON, and this meant that I could quickly add attributes and modify the data structure without having to fiddle with any schemas or do like alter table and try and remember SQL. So I have a domain stored like this on the left-hand side. So these are two domains, one of mine and one of my friends, and it says which account the domain's on, where the master IP is. And then on the right-hand side, here's an example of the metadata that I store on the Anycast location. So this is a box at Edinburgh hosted by Fluency. I store the country, the geo lat and long, so I can plot it on a nice map. Then I also store the management IPs and details about the peering session. So here I've got some communities that are set on the BGP session with them. This made it super easy. If I wanted an additional attribute to store some kind of preference for a box, I just added it as a JSON attribute and it was done. So what does that application look like? I built a REST API in Python and used Flask, which is a bit like Django, but super lightweight. And this is a cron job and rsync free zone. So typically when a lot of people, and I've done it in the past, and I'm really bad for this in past lives, is getting data onto maybe secondary zone servers. What you'd do is you'd rsync it from the master if you were lazy, and then you'd have a cron job that would do a RNDC reload every hour or such. And this is still how some DNS providers work today. So I thought that was really bad. So I wanted to play with message queues. So all my elements that are part of the service are actually scripts and daemons that connect to a message queue and listen for events. So as someone adds a zone via the API, put a message in the queue, and a service will be looking for a particular message. So as zones are added, they go into the database, and then the daemon that manages the DNS server sees that message coming in, and it prompts it to rewrite the configuration and reload that zone. And that means from the point that someone goes onto the API and adds, just for a REST call, adds a DNS zone, the zone can be live and be pulling on all the boxes within normally about 5 seconds. So data stored in RethinkDB. I also use Redis to store state. So on all the Anycast nodes, I pull things like BGP sessions and some counters about performance, and I check them back up over the API and store them in Redis. It doesn't matter if the Redis database gets cleared. It's just a key value store, because over the course of a couple of minutes or an hour, all that data will get learnt again. So everybody just talks to the REST API, and my barrier to entry has typically been if they can call the REST API, and I provide some examples with curl. There's no web interface at the moment. They can use the service. So after kind of thinking this through and drawing it up on napkin and stuff, I wanted to work out where I could host the nodes. It couldn't cost too much because I had that kind of initial rule of the $1,000 a year. So that ruled out renting colos and dedicated servers. I needed a really wide reach. So I thought maybe virtual machines. So I was considering swapping with friends, and then the other idea was to look at the low-cost hardware that's appearing these days. So I started thinking about how I could get my first node out there. There's a few kind of clueful hosting companies that everybody's aware of, and one of them I knew was Mythic Beasts. So I didn't know Pete, who's here today, before I sort of embarked on this project. So I looked on their website and saw they sold a £7 a month VM, worked out at 84 quid a year. It was 512 meg of RAM, 1 CPU, 10 gig of disk, and included a glorious 75 gig of bandwidth per month. So without kind of verifying that it would do what I needed, I bought it, got the SSH details, and then promptly opened a support ticket. They didn't have anything about BGP mentioned on their website, but I could see that they had one downstream customer on their network that was announcing some space. So I just opened a support ticket and I wrote, I have this /24 and a 48 of PI. Can you set me up a BGP session? And I included my macro details. And then I think it was in a couple of hours, I got an email back saying, here were these IPs and the session were ready. And that was super easy, and that gave me a bit of confidence to kind of plow on with the project. So after I had the one box up and I was announcing the space and my test zones were working, I was on a quest to find more friendly VM hosts. So one place to find these I found is a website called Low End Box. And this is a blog, it's like message board for providers that offer VMs for less than $10 a month. One thing I found, they're usually open VZ based, like Linux containers. But I needed to find VM providers that were using KVM-Zen or VMware, because I wanted my own routing table. Another place to find them I found was a Low End Talk. That's an accompanying message board. People will often post offers on there. And then the magic keywords on Google is a VPS BGP session. Brings up lots of people that offer this for various reasons that we go into later. So the second box I found was listed on Low End Talk. This time I was a little more cautious. I didn't want to buy the VM and not find that I could set a BGP session up to them, so I messaged them. And they said they support a BGP session on any VPS. So I went for this $80 a year. Again, it was a similar spec. It's got a little more bandwidth and a little more disk. But it was in Detroit. So this is the invoice that came through. It was $80 for the year for the VM with the BGP table. I thought this was awesome. I had 2 nodes up now and Anycasting for real. Then I had a Google alert on Low End Box on their website that I set up, and I saw a new VPS provider come up, and this was a company called LeapSwitch. They're based in Pune, or Pune, I think it's called, in India. And they offered $120 a year for 1 gig of RAM. I thought, oh, it's twice as much RAM, a little bit less disk, but more bandwidth. So I was going to go for this. And then I Googled some more. And I found a promotional code online. And this was a promotional code that I put into their website on the billing form. And it was for a $72 a year recurring discount. So then I had my third VPS was in total $48 a year with a BGP session. And that's like less than like a fancy takeaway on a Friday night. It was pretty awesome at this point. I was really excited that this one was up live. So moving on, by the end of October 2013, I started at the end of September. I'd had 4 VMs live. I already had a KVM host, a dedicated server myself with Dan Goscombe, so that was my A location. B was with Mythic Beasts. I had the Detroit and then the India boxes that I found. And spinning up a new VM was like super easy. I just got the SSH credentials, then I pumped the JSON into the RethinkDB. I normally wipe the box with the provider because I'm a bit not really trusting, so I'd put my own fresh Debian on there. I then install Puppet and done, and then time for pub, and the box would come up. So a few people I chatted to at events or on Twitter, and I had some offers for free VMs. One of them was from Fluency in Edinburgh. Another was Towardix in Boston. And then I had this interesting email from this guy called Simon. And he'd seen my GitHub project. I think he was searching GitHub for Anycast, and he offered just to swap a VM outright with one with him in Bremen in Germany. So after a month of this little project, I had 7 locations live. Lots of friends said, we'd love to host something for you, but not a VM. And there were various reasons why people couldn't offer me a VM. Maybe the folk that come to these type of events, they didn't have access to the VM hosts in their network. Or maybe they had no VM infrastructure at all. Or what I'm finding more and more of is that VMs were routed by the hypervisor. So the VM would be announcing the routes into the network. But those were sometimes static routes, and they were /32s, and They didn't want to bridge VM into their hypervisor, bridge BGP into their hypervisor. They weren't trunks. It was all routed to the hypervisor. That was a problem for me. So I thought I'd give a Raspberry Pi a go. So I took a 512 meg of RAM, $35 Raspberry Pi, and I overclocked it to 800 megahertz. So I sent this to David Farrell, who's normally here on the PC, in Belfast in a jiffy bag with some sweets and a USB power supply. It ran great. I was running NSD3 at the time, and I was doing 200 query per second. But the problem with NSD3 is it required a service restart when I was adding zones, so this wasn't great. I'd have to to do it nicely, I'd have to bring down the BGP session, restart, bring the BGP session up so no traffic was dropped. So I swapped out to PowerDNS on the rest of the network with Puppet, and this was like just in a hotel room when I was in the States, and I flipped it out in about half an hour, just chasing templates. And then I hit a problem. I never actually tried the PowerDNS control program on a Raspberry Pi. All my test boxes were x86, and PowerDNS control just started segfaulting on the Pi. So then I didn't go out that evening, I stayed in, and I then decided just to flip it all to bind, where it is today. It got to January, and I thought maybe I'd give this peering lark a go. My friend Matt that I work with in San Francisco runs SF Mix, community IX out there. He offered that I could put a box in their rack in 200 pool, and I couldn't really turn this down, so I had to have a think. So I needed two NICs, one to do the management over and another to connect to the peering fabric. So I found this Fit2 PCI, which you can see here, it's just stuck down the side of the rack, so it's using a 0U. It's an Atom with 1.6 gigahertz processor, 8 gig of RAM, and it had a little 16 gig SSD in there. It was $150 on eBay. So I put this in, and he gave me an IP and a little OOB connection that had no BGP on it, and I started peering. I had brought up peering sessions with HE, ISC Unwired, PCH, Layer 42, DO, and some others. And it wasn't until I gave this presentation at DNSOARC that these organizations realized what they were really peering with at that exchange. So I had problems with that Pi that was out in Belfast. It was super slow. Like running Ruby on a Raspberry Pi is like a dog. It's a single core box. Then I had some more offers to host hardware nodes, and one of those came from Grimsby Town fan Andy at Allegro. So I found this gigabit bricks on eBay. It was a quad core, 1.8 gigahertz unit. It's a bit like an Intel NUC. I normally have one in my pocket, but I forgot to bring one. It's 4 gig of RAM and has a 30 gig mSATA. So I swapped out the Raspberry Pi with David. This was in Manchester last year. I took the Pi along, and I took this along and just told him to keep the Pi, and I left Andy a gigabit bricks as well. So that's what you see here, just sat on top of their. I think this is on top of the box in Belfast at T-Bus, on top of their ME series switches. So this was as of the 3rd of November. I had 12 nodes live, 6 in build. And what was really entertaining was by the time I'd sat down at my seat after giving the presentation at RIPE, my DM window on IRC was packed with all sorts of people offering me logins. So this slide's now out of date. I think I have 18 live, and I've got a queue of about 13 in build. So I wanted to talk a bit about the fun I had along the way. I was often the first BGP customer for some of these VM hosts. They'd only ever set up BGP with maybe their one upstream or two upstreams. So I had to do with some assistance in education. There was a few occasions where if I took a particular node down, they'd still be advertising my routes to their peers. And this meant that I'd see my traffic dogleg via their network, even though my node was down. So I had to tell them that they shouldn't prefer their transit routes over their customers. I'd also seen on a few occasions people had no route maps or BGP or filter lists on their sessions to me. And some people didn't even have any communities, and this was a bit of a pain because typically when you deploy Anycast, you maybe pick 2 or 3 global providers, and then you just do local peering with no export. But I didn't have that benefit, so there's some folk like on the Goscom and Fluency that already had communities that I could exploit to manipulate my traffic, but others didn't. I used RIPE Atlas extensively to monitor my own network. I was looking at, I've got scheduled measurements on there which are public, and you guys can see that, to measure the latency and also gather the chaos ID.server from the DNS record. I recently started announcing an additional unique /48 anchor address, as they're called in this kind of setup from each instance. So each location announces the shared 48 plus its own unique one. And I could use this to kind of check that prefix filters were right and the BGP sessions were working for v6. And this gave me some visibility into their configuration. So I've been using ripestat. I just do an API call against ripestat to look at the presence of that unique 48 in Ripe's view of the world. So what was really surprising is that there's a market for these VMs with BGP sessions. So this is PORTLANE. They're in Sweden. And I'm not sure if you can see on here, but they have a tick box, and PORTLANE will offer you, here you go, put a BGP sessions an additional €10 a month. And sometimes that's a default, and in a lot of cases, some of these providers will actually give you a full table. Zetagrid, a BGP session, you just fill out the form on their website with the AS number and the IP range. Chaos. So these are some things that I discovered along the way as well. It's really easy to find the budget Anycasters because they're often the folk that are replying to these VM offers on message boards saying, does this support a BGP session? I came across some kind of interesting deployments. So one thing I'd find was there's a shared /24 that was being announced. So this is, they'd announce a /24 from every location, but they'd give people dedicated IPs on there with custom reverse DNS, all hosted off the same box. That's pretty typical for DNS providers, and they do slave zone. I was kind of happy with that. I was sort of experimenting that myself. Another thing that Anycast providers would do would be to offer to host someone else's /24 from all their locations, so that the IP address space was owned by their customer. The last two are super murky. There was often there's some Anycasters out there that offer a shared /24, but they would tunnel individual 32s back to you over GRE tunnels to your master back in your network. And this gives the illusion of Anycast. And you can see, like, when you ping it, you might get the reply from ICMP from the edge, but the UDP response would take a long time because it would be going back down the tunnel. It's like smoke and mirrors. And the last one is one that I find quite funny. There'd be some folk that will only have a /24, and they do Anycast on it, but they'll announce it from a single location where maybe they have their mail and their website and their management. And at other locations around the world, they'll announce it as a /24, but tunnel all those other IPs for their services back to their first location. Also found that not all budget DNS hosting companies host every zone at the edge. Sometimes they host the zone centrally, but just cache at the edge. So for frequently requested zones, they get the benefit of performance, but for those zones that don't have requests to them often, the request will always be going back to the central location. And the last point, some people will tunnel all DNS traffic back to a location. Looks like Anycast, NAF performance, and these GRE tunnels and /32s that I mentioned a minute ago. Also had to go at trying to be like Cloudflare. I spun up a HTTP server like HTTP on all my edge nodes, and I return a different JSON object depending on the box being queried. So you can just curl this local.esgob.com, and it will return some attributes from the edge location. So what next? I wanted to keep honest and keep hosting all the zones at the edge, which I've been doing to this time. I really need to get around to writing a web interface because I still have that barrier entry that you can fill out the registration form, but then after that, you have to use either write your own API, and I'm not sure is it Carl? Yeah, Carl actually contributed a Perl API on GitHub for using this, which was awesome. And I had a pull request from Tim Bray as well, who fixed some of my documentation. So I need to make my GitHub repos more consumable. I actually need some installation instructions if people want to take this framework and use it on their own networks. I'd like to support multi-master, so both within my network and outside, so I can take the zone from different upstream boxes that a user might have, and I'd like to do tsig inbound as well. One other thing I think it'd be kind of healthy to play about with is having JSON attributes attached to each Anycast instance. So on a per node basis, I can flip the routing daemon, possibly between Quagabird and ExaBGP, or between bind NSD and not for the DNS. And I'd like a mix of those. I'm still on the lookout for friendly hosts, particularly in these areas. And this is sort of, as of today, well, this picture is actually as of November, because I forgot to update my slide deck. So you can see this live if you get to my NOC website. And currently it's running, the running costs are about $480 a year, so it's got the seal of approval from the wife. So the takeaways for this is that it's a really low barrier entry, and this is super scary for a few reasons. You can get a VM with a BGP session for $40 a year. So if you do this, don't become part of the problem, or if you provide BGP sessions to your customers, check that your customers aren't hijacking prefixes. Always use IRR prefix lists and filter on your customer sessions. And have some kind of manual checking in the provisioning process. So some of these companies had a web form, and the BGP session would provision straight away, particularly in areas where they didn't have any sensible IRR at all. Using Anycast can improve the delivery of a service to your customers. And I encourage people to automate all the things and have fun and come to UKNOF and share projects that you've been up to. Are there any questions? Oh, sorry, Rob.
Hi, Ronan Mullally from Akamai.
Hi.
You mentioned one of the motivations behind this was performance, and that you used RIPE Atlas to look at it. Did you find at any stage that turning up nodes actually degraded performance?
Oh, yeah, pretty consistently. Sometimes I've made, like on the SF Mix location in San Francisco, I'd turn up my BGP session with Hurricane Electric. The V4 was fine, but then as they do that thing where when you turn up a V6 session with them for the first time, and they normally detect it, I just accepted the free transit from them. So then suddenly on my V6 traffic sort of got sucked into San Francisco. So I've been super cautious now about turning up locations and making sure that the places where I put nodes have communities as well. One of the ways I'm trying to fix that is I had a sort of an awesome offer from a friend, Alex, that's at DigitalOcean. Suddenly I found I had $5,000 credit in my DigitalOcean account. And he was like, oh, go ahead and just deploy like 4 nodes in each of our data centers, and we'll give you BGP sessions for them. And this is something that I should have jumped on, but I just haven't had the time. But what it would offer me is some consistency about the transit providers across the network, and I could localize traffic better. Just cherry-picking random providers can be painful, and that's one of the things that's illustrated in Bill Woodcock's presentation that I referred to earlier.
Okay, thanks.
Okay.
Hi, Nat. Marty from Cloudflare.
Oh, hello.
2 questions. First one is, are there any locations that you notice that providers or other networks just don't seem to want to route to because they've got better paths to other nodes?
I've had some problems, mainly around locations with exchange points. People will prefer for various reasons. Like on the network today, a lot of my traffic will go to Edinburgh because people prefer fluency over local peers. And that's things I'm trying to influence with these communities. I've had lots of problems with my nodes in India, where I'd set the BGP sessions up and then I wouldn't see the routes, even in other Indian ISPs. And there's often kind of local politics and things that I didn't necessarily want to get involved in. So in some occasions it was sometimes easier to just remove the node.
Second question is, do you find that if one node perhaps goes down for some reason, it causes a problem with other nodes being overwhelmed?
I'll be super honest.
That's a problem that we sometimes encounter.
I can imagine your traffic levels it is. Well, I think it was maybe Kathy that had done here might have asked at DNS OARC how many queries per second I was getting. And I think at the time it was measurable. It was probably not more than 10. So that was at the point when I only had a couple of zones. Shortly after that presentation that went up online, I had an email from a hosting company in Iceland, and they asked if I could host 15,000 zones for them. So at the moment, I've got just under 30,000 zones on the system, and the traffic levels it's pretty low, and I can handle the traffic moving about.
Do you ever suffer from any attacks that also cause a similar problem?
Not that I've noticed, but it's still early days.
Thanks.
Cool. I think that's it. Oh.
Hi, Gary Steers in True. Have you thought of, say, using the Cloud Monkey or other OpenStack kind of APIs to automatically deploy a VM to do this purpose?
So could you repeat the beginning of it? I missed the project that you referred to.
So there's things like CloudStack and OpenStack have their own APIs. Have you thought
Yep.
of writing an API yourself that will automatically deploy a VM?
I suffer with OpenStack at work on a day-to-day basis. I don't want to touch it in my free time.
Fair enough.
Cool. Thank you.
Okay, thanks, Nat.